So go ahead and get started. I want to talk about going ahead and securing AI agents and focusing on getting a return on your investment. And what I found when I talked to various folks, there's a really wide spectrum of perspectives on this situation. You go to one side, and some people are saying, my cybersecurity program, bulletproof, we handle all this stuff. There's not really anything new to worry about. And then there's other groups of people that are on the panic. This is a total novel AI world. There's all of our controls aren't going to be useful. There's like really extremes that I find. And really, the truth is in the middle, like most things. And to highlight this point, I want to go ahead and compare some of the threats that are identified in Maestro, a new threat modeling framework made for AI agents that was deployed back in February, and a modified version of Stride, which is an industry standard for 20 plus years, to kind of show the new and the old as a comparison, right? So what's really new and what's really old. We'll get there as we go on. So before I go further, what is Maestro and what is threat modeling? For those that aren't aware, threat modeling is just a thought exercise. It's a way to think about whatever you're building, what are the security things to address before you actually build it. And Maestro is a AI framework made by the Cloud Security Alliance that was published back in February of 2025 that was specifically created to address the unique nature of AI agents and the security threats that it could address. OWASP has also directly endorsed this by referencing it and applying its own AI agent taxonomy to this framework in their OWASP multi-agent system threat modeling guide. So pretty good industry standard of saying, hey, this is a good place to start if you want to threat model for AI agents specifically. Some of the reasons why it was created. It was created because it was determined that there was a gap in the existing threat modeling frameworks, or the existing way, or another way of thinking about it, the existing way that cybersecurity practitioners were evaluating systems that weren't covering the nuances of AI agents. And I'm going to specifically focus on Stride because I think it's the most widely used and understood. It's also the first one they called out. And so as a thought exercise, what we're going to do is we're going to go ahead and say, what would we have to do to Stride to handle the AI specific use cases in general, just as a thought exercise. So for those that aren't familiar with Stride, it's a acronym. Love acronyms, yay. For considering 6 things when you're threat modeling. And again, this is a framework that is 20 plus years in the making. You consider spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege threats. So what we're basically gonna be doing is I created 2 new categories that you could add to Stride for ML, or misunderstanding and lack of accountability. Misunderstanding is going ahead and covering any undesirable outcome that you would want from your model, whether it's because it doesn't have the right context or there's malicious intent. Lack of accountability is in this world where AI agents are autonomously doing a lot more and making a lot more decisions without some sort of guardrails or controls or whatnot. It's really easy to, when things go wrong, it's very easy to not know who's accountable for fixing it and resolving the situation, causing a lot of confusion. So what I did is I went ahead and we looked at the Cloud Security Alliance framework and the OWASP framework, and they each went ahead and they call out various sets of threats. The Cloud Security Alliance calls out about 50 unique threats, and the OWASP AI agent guide essentially calls out 15 unique threats. And I basically just mapped them into each one of those buckets, into either the traditional Stride or into the ML. And so the point of this is to highlight that there is truth to what the Maestro framework is saying, is that there is some unique novel aspects of Stride that aren't going to be covered by your traditional cybersecurity. There are some unique aspects of AI agents that aren't going to be covered by your traditional cybersecurity. But I think this proportion is way out overblown than what the reality is. And I think this is a good way to represent it by, 25% of the threats that are called out by the Cloud Security Alliance. I would say those would be truly novel to AI agents in the ML categories, but the other 75%, 76% are in stride, which is how we traditionally think of cybersecurity. And then OWASP, same logic. They have a little bit more refined nature in what they did in their taxonomy. So a little bit more is in that novel category, but it's again still 2/3 of that. You should be able to use your existing controls, mindsets, and capabilities to defend against these. And we're going to talk more about that. So great, that's great information, but what do you do with it, right? How do we action it? And that's what we're going to talk about now. So the goal is to understand the gaps in your cybersecurity program so you can go ahead and say, what can I utilize, what I already have? What can I extend or use creatively to go ahead and mitigate some of this? And what do I need to focus on? This is a totally different of kind. My existing capabilities probably aren't going to help me with mitigating these threats in the AI agent space. And that's where we're trying to help you focus on. So I'm going to go ahead to the next slide. So what I did is I went ahead and there's 3 buckets, as I just said, and I went to the OWASP AI agent taxonomy, and there's 15 threats there. And these 15 and these 5, I would say they're existing things. They are not new, and a lot of the mitigations you would do for these aren't really new either, right? I'm not going to go each one line by line in here because we're going to be releasing a paper soon that's going to list all the justification for each one of these, and also we can handle that in the Q&A and just openly discuss about it. So, but I'll give like one example. So the first one, identity spoofing. That's going ahead and having good access management controls. That's really not unique to AI agents. If you don't have good login for your machines and you don't have good login for your users interacting with them, you're going to be able to spoof them. So that's not really going to be really totally new. What is it's a new context, but not totally you needing new tools to go ahead and address. Let's take memory poisoning, for example. Going ahead and protecting your cache and your memory of where information is stored, where things could go ahead and be modified and could change the behavior of the agent. If that's going ahead and being tampered, it could change what the agent actually does. But that's something that we do now already, right? We go ahead and we cache customer data, applications, and if that was tampered, it would change what the application does. We do things that we make sure that only the right applications can go ahead and can interact with it. We go ahead and isolate it. There's a number of things you would do to ensure that only the right sources are modifying that memory. Yeah, as an example. And then these are the areas that I would say are truly, truly novel to AI agents, as in like we need new types of mitigations to address them. And these ones I am going to go ahead and take a moment to like explain line by line because they're the truly novel parts that I want. The point of this is for people to focus on these ones while looking on their landscape. So tool misuse. Right now, what that means is an agent goes ahead and it decides what it wants to do. And with that logic, it says, I'm going to call this API. I'm going to get this data. I'm going to take this action. Those are tools. And tool misuse is the tool ecosystem either going ahead and not saying that it does something and it doesn't, or the AI agent using those tools in an inappropriate way. Right now, that's not really something we have to deal with because either it's hard coded to the tool or the APIs to be called in very specific ways with logic code, or those tools are used by human beings and we trust them and delegate to them and we train them to go ahead and do it. So we don't really have tools to go ahead and autonomously put rails on that. We just rely on human judgment to do that. Cascading of hallucinations. This is where things are made up. right? You've gone to ChatGPT and typed in, and it just made up facts, right? As right now, with basically how these work is they have a source of truth, they collect information, and they give a response on what to do or whatnot. And it can just make up information. It gives its best guess based on the best data that it has access to. Most of our applications, they're deterministic in nature. They go ahead and you write code, it goes ahead and clears this data, and it shows you that data and changes it or whatever. It's not going ahead and on the fly essentially creating new data for each interaction. That's a new type of thing to consider. Intent breaking is if the user wants to go ahead and book a trip to Italy, let's say it's a travel agent, and it wants to book a trip to Italy, and instead it books a trip to Spain, that's not the intent of the user. It misunderstood the user's intent and is breaking it. Now that's just quality of the agent. You could also go ahead and take that further and do malicious intent. And if the intent is for you to book your own travel, like for travel services or whatnot, if the intent isn't aligned, it could go ahead and say, let's do lateral movement and interact with a totally separate system inside the company, right? That is not the intent of the agent, but it potentially could have access to it and changing the intent of what it's supposed to do. Um, Misaligned behavior is going ahead and is basically called out because AI agents don't have any sort of ethical code. So misaligned behavior is, does it align with ethical standards and things that a human being, if they were told to go ahead and do something unethical, they probably would stop it. So a good example of this is, I'm going to use a very extreme example, is to go ahead and say, what's the fastest way to stop climate change? Maybe the fastest way to stop climate change is to kill all people, right? It's kind of unethical, right? I don't think a human being would go ahead and seriously put that on the table, right? But if that was its core goal of let's reduce climate change and human beings are the root cause, maybe a natural conclusion for would be to kill all people, right? And so that's kind of that's kind of where agents don't have an ethical guideline or moral compass inside. And so by relying on the agents too much, it makes it so that way people could be, when those things happen, who's accountable for that unethical behavior, right? It would be really, really unclear without clear governance or things like that. And then human trust manipulation, it kind of falls into this as well. If people go ahead and trust the input and output of these agents and machines too much as gospel, then they could go ahead and just kind of, when things go wrong, they just blame it on the chatbot or blame it on the system, and not really apply their own critical thinking. But that's also, to be fair, if you don't give the human operator clear visibility of what's going on, it's not unfair to expect, like, they don't really have another option but to kind of blindly trust it. So again, a lack of accountability is making sure to say, hey, when there's things that go wrong, what person or group would be accountable for actually addressing it, not just saying the agent did it and throw your hands up. That's not a great spot to be in. So I'm gonna real quickly, this is like a one slider of what I just talked about. So these are the threats that you should focus on. The OWASP AI agent threat taxonomy. Again, on the left-hand side is things that you probably have already at your company to address. You already probably have tools, processes, and people to address. In the middle, probably you can extend a little bit what you already have, and again, we can talk about these more in the Q&A. And on the last part is what is truly, truly novel, which I just went over. And this is where you're probably going to need to search the market, the marketplace, vendors and things like that that are focusing on this to help address and solve and partner with these kind of threats to realistically address. So I just show kind of the threats to be concerned with and kind of how to prioritize them, and where you can probably most likely find those solutions with what you already have. And then also these are the other way to look at it is what do you do? So in the Maestro documentation, um, it does at the end. It basically says these are the mitigations you should focus on, and it says these are basically general cyber hygiene things you should focus on and things like that. These 5 things are specifically what you should do to address those AI specific threats. Um, and I'm going to explain them because, again, these are the capabilities that you're going to need to bring into your company. Whether you build it in house, you buy it, or you accept the risk of not having these things to realistically mitigate against a lot of those threats that I just talked about. So, adversarial training. So, if you're training your own models in house, um, not only training for the happy path, not only saying these are the good examples, but purposely putting in some uh, not ideal examples, some malicious examples in there, and saying these are bad. So that way the model itself knows what is good and bad, essentially. Formal verification is how are you ensuring that your agent is doing what you think it's doing, what it should be doing, within the scope of the purpose of that agent. AI explainability is how do you turn that probability space, that black box, into something that human beings can actually understand what's going on, audit it, and given a input or given a decision that was made, there's some transparency on how that decision was made. So that way we don't get in a position where if you're running a mortgage company and you're running your AI system and you have one customer that was denied and another customer that was approved, and you say why, you have a better answer than saying the AI told me so. You can say, well, this is the justification, this is the data that went ahead and triggered it, things like that. Um, red teaming. So there are lots of there are automated tools coming the on the uh, on the horizon, but I do think there's going to be a need for skilled practitioners, red teaming, and constantly finding those new vulnerabilities to find those 0 days over time. So finding those new types of prompt injections and things like that, because the space is so evolving, to find all of the threat landscapes and have tools that are going to address it all is gonna be tough. And then safety monitoring is real time going ahead and in runtime monitoring, is the input and the output that's going into my model safe and secure? Is it doing toxic language? Is it doing things like that? And those are the 5 key recommendations to address those AI specific things, and then a lot of the other things should be things you're already doing or capabilities you already have from a strong cybersecurity program. So thank you for your time. We're about to go to Q&A, but before we do that, we're going to have another session on June 25th with the CEO of AIceberg, Alex. He's going to be talking about designing with intent, securing autonomous agents. And you can go ahead and if you'd like to register there, you can go ahead and scan there. And thank you for your time, Jonathan. I think we can open up for Q&A.